Good morning, students. Our next concept is concurrent lines. Before that, you just see our well-known concept intersecting lines. So, point of intersection of two lines a1x plus b1y plus c1 is equal to 0. It is one line equation. And a2x plus b2y plus c2 is equal to 0. This is another line equation. So, point of intersection of these two lines is in generally, that means coordinates. That means the coordinates of this point like this. For suppose this is first line, this is second line. This is called the point of intersection of these two lines. This point of intersection is nothing but coordinates x comma y. That x comma y is nothing but b1 c2 minus b2 c1 by a1 b2 minus a2 b1, c1 a2 minus c2 a1 by a1 b2 minus a2 b1. You know how to solve. That means solving means finding intersecting points. How to solve? Elimination method, substitution method, cross multiplication method. If you remember this formula also, we can get the directly answer. So what is here? A1, B1, C1 are nothing but coefficient of x, coefficient of y, constants in first equation. A2, B2, C2 are nothing but coefficient of x, coefficient of y, constant in second equation. And based on these constants, we have b1 c2 minus b2 c1 by a1 b2 minus a2 b1, c1 a2 minus c2 a1 by a1 b2 minus a2 b1. Okay, so actually how you get, you see here. So already I am explaining about cross multiplication method. So if you use cross multiplication method, you get this formula. So go for x y1. Already I explained how to write this one. X y constant place you have to write 1. So here we should write coefficients of y, constants, coefficient of x, and coefficient of y. Again, we have to start with and end with y coefficients. See here, coefficient of x, y constant is a1, b1, c1 for first equation. So you have to write here b1, c1, a1, b1. Again b2, c2, a2, b2. So after that we have to write cross multiplication of these two. First b1 c2 minus b2 c1, x by b1 c2 minus b2 c1 is equal to y by c1 a2 minus c2 a1 is equal to 1 by a1 b2 minus a2 b1. To get the value of x, equate these two. To get the value of y, equate these two. So x is equal to transpose here b1 c2 minus b2 c1 by a1 b2 minus a2 b1. Y is equal to c1 a2 minus c2 a1 by a1 b2 minus a2 b1. This is the point of intersection of the given two lines. So if you remember this formula, you just directly apply. Otherwise, you go for this procedure. No problem. So next one, concurrent lines. Whenever two lines are intersecting, that intersecting point is called point of intersection. Whenever three or more than three lines are said to be concurrent, okay, if the lines are passing through the same point and the point is called point of concurrence. That means if you take generally, if you take three lines, this is first line, second line, third line. Whenever you have like this, these three lines are passing through this same point. Yes, if you want to take one more line, you can take like this. No problem. You can take like this, one more line. So we can take infinitely many lines like this. This point is called point of concurrence of these three lines or four lines, five lines. For suppose whenever you have like this, this is not point of concurrence of these three lines. This is not point of concurrence. This is not point of concurrence. So this is wrong. Like this whenever. Okay. Three or more than three lines are said to be concurrent if the lines are passing through the same point and the point is called point of concurrence. For two lines, point of intersection. Three or more than three lines, point of concurrence. Okay, so very important concept. This application, you see, you just remember these applications, very important. a1x plus b1y plus c1 is equal to 0, a2x plus b2y plus c2 is equal to 0, a3x plus b3y plus c3 is equal to 0 are concurrent, then concurrent means, so let us consider these three lines are like this. This is point of concurrence. So whenever these three lines are concurrent, then we have two applications, very very important. Which one is suitable to solve the problems, we have to apply that one. Okay, so first one is here, coefficients of first equation a1 b1 c1, coefficients of second equation a2 b2 c2, coefficients of third equation a3 b3 c3. This is called determinant form. Okay, determinant of a1 b1 c1 a2 b2 c2 a3 b3 c3 is equal to 0. Whenever three lines are concurrent, just you write their coefficients, okay, in a 3 by 3 determinant, and make that is equal to 0. Whenever, if you want to show these three lines, generally they may give coefficient of x, y constants or numericals. So whenever if they given numericals and asked to show that the given three lines are concurrent, then if you get this determinant is equal to 0, then you can say directly those three lines are concurrent. In another procedure, but suppose if you actually this is the point of concurrence, that means the point of intersection of these two lines satisfies third equation. That means, so in regularly if you go for that method, first you find take any two lines and find the point of intersection and substitute that resulting point in third equation. If that satisfies third equation, then you can say those given three lines are concurrent, otherwise those are not concurrent. Okay, so that is little bit lengthy. So if you go for a determinant, so new joining students, maybe you don't know, because of already old students we completed matrices and determinants. In determinants I explained how to expand. So whenever explaining about a determinant, I will explain how to expand, so don't get tension. Okay, so a1 b1 c1 a2 b2 c2 a3 b3 c3 is equal to 0. And so already I explained regular method, that is finding the point of intersection of first two lines or any two lines and substitute in the third line. If satisfies, those are concurrent lines. So shortcut method, this is the determinant is equal to 0. And sometimes it is not able to apply this determinant form, then you have to take this method. So the second one is lambda 1 L1 plus lambda 2 L2 plus lambda 3 L3 is equal to 0. Here lambda 1, lambda 2, lambda 3 are scalars. Scalars means constants. Constants means numericals. Any number, no problem. For suppose first something into some 2 into L1 first equation plus some 3 into second equation minus 1 into third equation. You take any numbers, numericals. Okay, if that sum is equal to 0, then you can say L1, L2, L3 are concurrent lines. Understand? So don't get tension about lambda 1, lambda 2, lambda 3. Your lambda 1, lambda 2, lambda 3 are any numericals you can take. Okay, so this is the applications of concurrent lines. You just apply these applications. Okay, I will explain how to use and when to use these, which application is suitable to which problem, I will explain. Okay, next one. Form the equation of the line passing through the point of intersection of two lines L1 is equal to 0, L2 is equal to 0 is. So this is also one of the method. Form the equation of the line passing through the point of intersection of two lines L1 is equal to 0, L2 is equal to 0 is lambda 1 L1 plus lambda 2 L2 is equal to 0. For suppose if you take this is L1 is equal to 0, this is L2 is equal to 0. Okay, if you want to find out any line passing through point of intersection of L1 and L2. Okay, L1 is equal to 0 and L2 is equal to 0. Then these three lines are concurrent lines. If you want to find out this line may be in the form of some lambda 1 L1 plus lambda 2 L2 is equal to 0. In other words, it is a constant, it is only constant. If you divide entire equation with some lambda 1, then how it will be? L1 plus lambda 2 by lambda 1 into L2. is equal to 0. Okay, here lambda 2 by lambda 1 also some constant. So that constant you take as some lambda also. Then you get this formula. So that is L1 plus lambda L2 is equal to 0. Other words, okay, if you divide the entire equation with the lambda 2, then how it will be? Lambda 1 by lambda 2 into L1 plus L2 is equal to 0. Here lambda 1 by lambda 2 we can take as some lambda. Then how it will be? L2 plus lambda L1 is equal to 0. That means if you want to find out, if you want to write any equation, okay, any line equation which is passing through point of intersection of given two lines, L1 is equal to 0, L2 is equal to 0, then you can use any one of these three forms. Okay, now then we can say one thing, this L1 is equal to 0, L2 is equal to 0, and this form, any line equation which is in this form are concurrent lines. That is very, very important, we should remember. Okay, now that is I explaining here. That is L1 plus lambda L2 is equal to 0 represents the set of concurrent lines whose two members are L1 is equal to 0, L2 is equal to 0. Just now I explained same thing. And point of concurrence is point of intersection of this point of concurrence. What is that? Very clearly we can say, if you know very clear two lines, point of concurrence of these three lines is nothing but point of intersection of these two lines, L1 is equal to 0, L2 is equal to 0 only. Very clear observation. So this is L1 is equal to 0, this is L2 is equal to 0, this is some L1 plus lambda L2 is equal to 0. This point of concurrence is nothing but very clear line equations. What are here? L1 is equal to 0, L2 is equal to 0. That point of intersection only, point of concurrence. Here L1 plus lambda L2 is not clear line equation. So because of, if you know lambda, okay, otherwise it is a little bit difficult. So that's why if you want to find out point of intersection of this point of concurrence, that means the point of concurrence of these three lines, if you want to find out, go for point of intersection of given two lines. Okay, very clear. Next one. Orthocenter of the triangle formed by L1 a1x plus b1y plus c1 is equal to 0, L2 a2x plus b2y plus c2 is equal to 0, L3 a3x plus b3y plus c3 is equal to 0 satisfies. So whenever a triangle formed by, okay, these are the sides, these line equations are nothing but sides. So then orthocenter of that triangle formed by those three lines satisfies this condition. That is nothing but L1 into A2 A3 plus B2 B3. Here in the L1 you never get a A2 A3 or B2 B3. So L1 into A2 A3, that these L2 L3 are nothing but second and third line equations, coefficients of x. Okay, so L1 into A2 A3 plus B2 B3 is equal to L2 into A1 A3 plus B1 B3 is equal to L3 into A1 A2 plus B1 B2. So this is a condition. The orthocenter of the triangle formed by the given three lines satisfies this condition. Here L1 means just multiply entire equation with this constant A2 A3 plus B2 B3. L2 means this entire equation multiply with this one. And L3 into this one means entire equation multiply with this one. So proof of this one I will explain here. You know orthocenter. What is orthocenter? The point of concurrence of altitudes is called orthocenter. Okay, altitude means the perpendicular draw from the vertex to opposite side. Yes. So now here equation of first you to go for triangle ABC. This is ABC. So BC line you take as L1, AC line you take as L2, AB line you take as L3. So drop two perpendiculars AD and BE. So this is nothing but point of concurrence of altitudes. If you go for another altitude, some CF also if you take, just without confusing I am writing only two lines. Okay, two altitudes only. So based on this one we have to show that condition. Okay, here observe here, this is AD also one of the line. This is passing through point of intersection of AB and AC. Okay, so that means AB, AC, AD are concurrent lines. So we know AB line and AC line. Then AD line will be, how it will be? That is nothing but some L2 plus lambda into L3 is equal to 0. Yes, so that is only we have to write. The equation of AD is L2 plus lambda L3 is equal to 0. That implies A2x plus B2y plus C2. Just write L2 line equation and L3 line equation here. A3x plus B3y plus C3 is equal to 0. So we got clearly AD line equation, how it will be. It is like nothing but this one. Okay. So AD, now you can observe AD is the perpendicular to BC. Then what can you say? Slope of AD into slope of BC is equal to minus 1. Okay. Slope of AD is nothing but, what is here? Slope of AD. Slope of AD is nothing but minus coefficient of x by coefficient of y. We know about slope of line equation. Slope of line equation, some ax plus by plus c is equal to 0 is what here? Minus a by b. Minus a by b means minus coefficient of x by coefficient of y. Similarly, here minus coefficient of x means a2 plus lambda a3. Here two x terms are there. If you simplify, you get a2 plus lambda into a3. Okay, minus of a2 plus lambda into a3 by coefficient of y means b2 plus lambda into b3. So b2 plus lambda into b3 into, what is the first line equation slope? Very clear. First line equation is nothing but a1x plus b1y plus c1 is equal to 0. That means minus a1 by b1. So just you write minus a1 by b1 into minus of a2 plus lambda into a3 by b2 plus lambda into b3 is equal to minus 1. So simplify. So minus into minus get cancelled. That is positive only. a1 a2 plus lambda into a1 a3 by b1 b2 plus lambda into b1 b3. So denominator transpose to right side, you get a1 a2 plus lambda into a1 a3 is equal to minus of b1 b2 plus lambda into b1 b3. So lambda terms one side and remaining terms transpose another side. You get a1 a2, this minus b1 b2 transpose this side, plus b1 b2 is equal to minus lambda, this minus multiply to inside lambda into b1 b3. So minus lambda into b1 b3, this lambda a1 a3 transpose this side, then you get minus lambda a1 a3. So in right side both terms, that means lambda terms both are negative only. So take that negative minus. So minus lambda if you take common, then you have a1 a3 plus b1 b3. Okay. Now what is here lambda? Lambda is equal to, so this minus a1 a3 plus b1 b3 transpose left side, then we have minus of a1 a2 plus b1 b2 by a1 a3 plus b1 b3. So now this lambda substitute here L2 plus in L2 plus lambda L3, then what you have L2, this is minus of a1 a2 plus b1 b2 by a1 a3 plus b1 b3 into L3 is equal to 0. If you take LCM, so what you have L2 into a1 a3 plus b1 b3 minus of a1 a2 plus b1 b2 into L3 by a1 a3 plus b1 b3 is equal to 0 if you take LCM. So this denominator transpose to right side, 0 into anything is 0 only, then we have this step. Okay, after that you transpose the negative term to right side. What you have a1 a3 plus b1 b3 into L2 is equal to a1 a2 plus b1 b3 into L3. So I proved these two conditions, a1 a3 plus b1 b3 L2 L3 into a1 a2 plus b1 b2. So same if you apply for BE. Okay, here I applied AD. If you apply for BE based on L2 and L1, you get based on L2 and L1 you get this relation. So now you prove this one. If you prove this one, so both are, all these three are equal. Okay, this is the proof of this one. Similarly we can prove. Okay, I am not proving. Okay, just you remember the procedure. Okay, next one. Similarly we can go for another one, that is based on centroid. So I am not proving. If you want to prove, you prove this one. Just I am giving the application only. Similarly, in the above, centroid satisfies. If you go, it is the you are taking here altitudes. If you go for medians, then you get this condition. Similarly, in the above centroid satisfies L1 of A2 B3 minus A3 B2. Reverse. Actually, here L1 of for altitudes. That means for ortho center we have A2 A3 plus B2 B3 we got. So but here L1 of A2 B3 minus A3 B2. A2, and that means coefficient of x and coefficient of y, just multiply. Okay, so the L1 of A2 B3 minus A3 B2 is equal to L2 of A3 B1 minus A1 B3 is equal to L3 of A1 B2 minus A2 B1. So this is one of the application based on concurrent lines. Very, very important. This is for centroid. This is for orthocenter. Okay, remember. So based on this, I will explain some problems.